And first of all, I would like to thank Tomsk University to ask me to join to this conference. My presentation was titled Meta-heuristic Techniques and their applications. I am Mohamed Elaziz, belong to Tomsk University and also Zagazig University. This is my contact if everyone wanted to ask me for research or something like that. In my presentation, I will discuss meta-heuristic and also application for global optimization and image segmentation. We're going to also to study or explain how we can use meta-heuristic techniques in medical application, also in cloud computing and engineering and economic application. And the last point in our presentation about the conclusion and the future work for meta-heuristic and its application. In general, we can define the meta-heuristic techniques as a computational method which simulated the natural process. These techniques can be categorized into six families. The first of one is called evolutionary algorithm, swarm intelligence, natural phenomena, sport algorithms and physics and mathematics. Last one is called the human inspiration. Each point or each technique from this meta-heuristic techniques have many different techniques. For example, in genetic algorithm and genetic programming, differential evaluation, all of them belong to evaluation algorithm. There is another one that called swarm techniques. This swarm techniques or swarm intelligence have many other algorithms such as grey wolf, particle swarm, artificial bee colony, and other. The main difference between these algorithms is how we can inspire from the nature or from the physics or from sport. Actually, the main difference between these meta-heuristic techniques and the traditional method like gradient descent or Newton-Raphson or something like that is that this method that called the traditional method is easy to implement it. However, this traditional method can be stuck in local optimal. Also, they required many gradient information from the function or the applications that we're going to using the techniques. However, the meta-heuristic techniques can benefit from a stochastic component and don't need to the gradient information. Also, they have different ability or operators that can be applied to improve the ability of searching about the optimal solution. According to this behavior of meta-heuristics, they have been applied to different applications. This application including for some engineering design problem or numerical or structure optimization function, also for image segmentation and feature selection and other applications. The first application we can discuss here in our presentation, maybe we will start by global optimization and the other application. But before this one, we focus on one of them that called swarm techniques. This swarm techniques aim to emulate the behavior of birds or animal or bee or something like that. In nature, we can say the animal can live in population or swarm and try to catch prey. The first, if we consider in nature, we can consider this is the population and this is the prey. And this green rectangle represents the search of area that contains the swarm and prey. So the main task here, how to find the prey. If this swarm knows the location or the position of a prey, all of them will catch the prey. Otherwise, they will spread in the domain and search about that prey. This actually we wanted to simulate it in our optimization techniques. After some evaluation, this evaluation may be the distance between the solutions or the agent in the swarm and the prey. So according to the best one, the other solution or other elements will follow it and update their position. The next step is to update the solution again and determine the best one. Best one here in our algorithms or our optimization techniques mean the best solution. After that, we updated the solution again until found the best solution, and this one is considered the best one and the best prey. For that, we wanted to use the meta-heuristic techniques in our applications. The first application here is the global optimization. The global optimization is a set of functions that have many different points that consider as local or global optimization, and we want to determine the best of them. According to the behavior of a global optimization, they have been applied in different real applications such as classification, scheduling, and parameter estimation, and medical image classification, and other. Here, we wanted to see how we can provide a new meta-heuristic technique and apply it for global optimization. According to our study, we wanted to improve the behavior of one meta-heuristic algorithm called sine cosine algorithm. This sine cosine algorithm is dependent on the two triangular functions that called sine and cosine, and we using both of them to update the solutions in the current population. And this is the step of how we can update the solution according to the behavior of sine cosine algorithm. However, this sine cosine algorithm has some problem, and this problem maybe affected the performance of the sine cosine during the searching about the optimal solution. This limitation is dependent on the initial population. This initial population may be affect on the convergence of the algorithm. To generate the optimal solution from this point, we can consider we have a set of solutions. This a set of solution may be considered as a green circle. This is the initial one. After some iteration, this we found the best solution. According to that best solution, all other solution will follow the red one. However, this red one maybe is an optimal one. Maybe the optimal one in the opposite direction. This opposite direction, we needed to follow it. So this is the considered opposite-based solution. To solve this problem or this limitation, we can using opposite-based learning techniques. That depend on the equation number 6. It depends on the lower and the upper and the current solution. The main important point for this one is to find the opposite direction for the current one, and then determine if the current one is better or it is best. It is the opposite direction is the best. This one can benefit for selecting the initial population. To make this more clear, we can consider if we have 5 solutions, and we want to determine if this one is the best or it is opposite one is the best. So we computed the opposite direction for each of our solution. The next step is to determine the best of the 10 solutions. I mean here we have 5 solutions in the first. After that, we computing the opposite best solution for each of them. So we have 10 solutions now. So we want to determine the best of them. This best one we can use to update the solution in the next iteration, and this can lead us to convergence fast to the optimal solutions. According to this behavior, we developed algorithms that called the opposite sine cosine algorithm, and this opposite sine cosine algorithm has been applied to different global optimization functions. Here some of them, this is example of these functions, and here this is the dimension of each of them and the lower and the upper boundary for each of them. This is the results obtained by using the opposite sine cosine algorithm. From this results, we can see the opposite-based learning has largest effect on the performance of sine cosine when compared to the proposed one with the traditional one. In addition, we compared the proposed sine cosine algorithm with other techniques such as opposite BSO, and we found that the sine cosine algorithm has largest effect and provide better results than BSO. The next point, we also try to apply new techniques that called Green-Wolf optimization by combining it with different techniques such as chaotic opposite-based and differential evaluation. Here in general, the Green-Wolf optimization techniques is aimed to emulate or simulate the behavior of a prey and how can catch the prey in the nature. This is the steps of the traditional Green-Wolf algorithm and how can catch the prey or how can find the optimal solution. In general, this one can be divided into exploration and exploitation. This is the two main phases in meta-heuristic techniques. If anyone wanted to update the meta-heuristic techniques, can update it either the exploration or exploration phase. Here we try to using different techniques to improve the gray wolf optimization techniques. First of them, we using chaotic logistic map. The second one is using OBL. After that, differential evaluation and disruption operator. All of these techniques can be combined together with gray wolf optimization to improve its behavior. However, each of these four techniques has its own task. For example, the chaotic maps are used to generate the initial population. As we say before, the initial population has largest effect on the convergence of the algorithm. So we're using here the logistic map to generate the initial population. However, there is many different chaotic maps can be used. But according to our experimental and other experiment from literature, we found that the logistic maps is better than other one. In addition, we're using the disruption operator. This disruption operator has been used to improve the exploration ability of several meta-heuristics, since it depends on the distance between the current one and the current neighborhood solutions, and also maybe depend on the best one and the current one. This, this used to improve the diversity of the solution during the searching process. The next, uh, the next algorithm we're using to improve the gray wolf is called differential evaluation. As we know, the differential evaluation depend on three operators that called mutation, crossover, and selection. All of them has different improvement or has different effect on the performance of the algorithm. According to these techniques, we combined them in one algorithm and applied to improve the performance of a gray wolf algorithm. In first of our algorithm, we generate the initial population according to the chaotic maps. After that, we apply OBL to determine the best initial population. After that, we're going to update the solution. However, here we can use either the operator of gray wolf optimization or the operator of differential evaluation. After we updating the solution according to this one, we can apply the disruptor operator. To evaluate the performance of this algorithm, we're using different global optimization techniques, some of them from the computational for 2014, and this is the behavior or this is the definition of each function. And this is the results obtained by our algorithm. From these results, we can see the high performance of the operators that combined with the gray wolf as we compare it with the traditional gray wolf algorithm. However, we're going to apply this new techniques to real application. This real application including galaxy image classification. This galaxy image classification is collected from different space or galaxies, as we can see here from catalog called EFIGI. This catalog contains four types. These four types, we can see the most similarity between these techniques or these images, and we needed to make classification for each of them. To make this one, we converted our algorithm from working only for real or continuous function like a global optimization. We're using our algorithm as a feature selection method. This is the main modification here, or the main point here is to convert from real to discrete algorithm. Actually, to make this one, we using or we convert the current solution in the population according to this function to become Boolean vectors that contain only 0 and 1. According to this value, we can determine which feature is the most important and which feature we can ignore or remove from our extracted features. To evaluate the performance of the selected features, we're using this current fitness function. According to this function, we determine the accuracy of our algorithm and to compare between the current solution and the other solution in the same population. From this one, we found that the proposed algorithm can get the smallest number of selected features with the smallest in smallest number, sorry, in smallest CPU, and also has high accuracy over other algorithms. This is the first application we want to see how can we using meta-heuristic techniques. Another application we can apply the meta-heuristic technique for it is called image segmentation. In image segmentation, we mean we want to spread the image into its component or into it is the smallest classes. There are many image segmentation techniques have been proposed, such as clustering and thresholding. However, the thresholding image segmentation method have more attention than other approach due to their simplicity and high accuracy against the other methods. So, in general, we can divide the image threshold method into groups. The first one is called bilevel, second one is called multi-level threshold. For the bilevel thresholding, we only wanted to determine only one value that called the threshold value that spreads the current image in two classes. However, in our real application, the image cannot have only two objects. So we want the multi-level threshold to apply and using it to apply for this image segmentation problem. The problem definition of the multi-level thresholding is illustrated by considering a gray level image I to be segmented and consisted of k plus 1 classes. The case thresholds are required to divide the image into subgroups. This can be seen from these equations in which each classes has its own pixels that determine or that satisfy this condition, and C1 also contains the pixels that satisfy this condition, and CK is the class number K that satisfies this condition. So to determine this threshold value that called T1, T2 until Tk, we needed to convert this one into optimization problem. This optimization problem can be considered as this equation that consider as a maximization function. Here, the two most popular function used are the Otso and the Kebor function. The Otso function defined by this equation and the Kebor function divided by this equation. In general, there are many algorithms or many function can be used as objective function and applied for image segmentation. Actually, in our work or our presentation, we only focus only on Otso and Kebor functions. In this application, we apply two algorithms that called whale optimization algorithm and the moth flam optimization for multi-level thresholding image. In general, each of these algorithms has its own behavior and simulated different phenomena from nature. For example, the moth flam inspired from natural behavior of moths which have a special navigation style at the night since they fly using the moonlight. The whale algorithms emulated the natural cooperative behavior of whales during the searching about prey. Here, this is the style or the flowchart of our algorithms and how can be used to find the optimal thresholding value. First of all, we generated the population according to these equations. After that, we computed the fitness function and updated the solution using the operators or the equations of each algorithm. After that, we repeated this until find the optimal solution and satisfied the condition or end the condition. To evaluate the performance of our algorithm, we evaluated by using different image from nature and compared it with different algorithms. Also, we using some definition of we using different performance measures such as BSNR and SSIM. Both of them is the most popular measures are used in image segmentation application. This is some results from our paper. And first, the BSNR and SSIM, we found that the both algorithms that called whale and the Mosiflam can provide little better performance better than other algorithms. Also, we using an ANOVA test to compare if there is significant difference between the results or not. According in most results, we found there is significant difference between our algorithms and other techniques. The next point now, how we can using meta-heuristic techniques in medical applications. Here we will study only one application that is called COVID. COVID-19, as we know, it is spread in last of 2020, and most of them to determine if the cases or the patient have COVID or not, and it is most expensive. So we're using image classification or image processing to determine if the cases has COVID or not. In our techniques here, we combined deep learning and meta-heuristic techniques. And first of all, we're using two datasets only. One of them is from Italy and another one from China. This is the related work for the COVID that published according to some techniques. In our algorithm or our technique, we extracted the features from the image by using CNN networks that is pre-trained based on the ImageNet dataset. This technique is called inception. The main aim of using this inception network is only to extract the feature from the image. After that, we're using a modified version from a new meta-heuristics called marine predator algorithm. This marine predator algorithm we modified it by using fractional calculus or fractional order, which aim to support the meta-heuristic by memory to improve their performance during the searching process. This is our algorithm or flowchart of our algorithm. And first, we extracted the feature by inception techniques. After that, we divided the data into training and testing. After that, we're using the training set to determine the relevant features by using the operator of modified version of from MBA or marine predator algorithm by using a fractional calculus. Fractional calculus or fractional order used here as a memory for the algorithm that saves the previous position or previous values. After obtain the best solution that considered his as the best relevant features, we reduce the size of testing set according to it and evaluated the performance of our algorithm. This is the result of our algorithm by using two data sets. From this one, we're using the smallest fitness function for our algorithm, FOMBA. And also, here we found that the smallest number of features are obtained by our algorithm. However, the CPU time is considered higher than another algorithm that called SMA. And this is the convergence behavior during the optimization process. And also, this is another measures that such as F-score and the time and determines the best value according to the accuracy. The next application here is called task scheduling in cloud computing. Can be considered one of most important technique in cloud computing and also on fog computing and also related to Internet of Things, by the way. In general, the cloud task scheduling problem can be defined as how to schedule and allocate various tasks to different virtual machine. Actually, we can consider the cloud system consists of npm physical machines that consist of n virtual machines. The main objective here is to reduce the make span by locating the best set of tasks to be executed on virtual machine. This can be represented by these equations 15, and also we needed to determine or computing the required execution time. So according to this one, we converted the task scheduling problem to optimization problem. This is some techniques have been proposed before and the behavior of each of them. In this application, we using different meta-heuristic techniques that called moth search algorithm. This moth search algorithm depend only on two equations. One of them represented the exploration and another one represented the exploitation. As I told before, this is the main two phases in meta-heuristic techniques. However, we using differential evaluation to update the performance of MSA or moth search algorithm. And this is the behavior, this is the flow chart of our algorithm. We're using the differential evaluation here to improve the exploitation behavior of MSA or moth search algorithm. Actually, this problem can be considered the most important problem in cloud computing, and also this problem is considered as a discrete problem since here we have integer solutions or integer value during the optimization. To evaluate the performance of our algorithm, we're using a cloud sim as an environment or a simulator, and also we compare the performance of our algorithm with BSO, with whale and SMA, traditional SMA, and also we're using some heuristic techniques such as SGF and RR. From these results, we can find that the proposed algorithm that called MSDE has better results than other algorithms, especially it has the smallest make span value. Also using a real data set. This real data set, it is this real data set from collected from HPC2 and NASA IBS-SC. From these results, we divided both of these results in small and large tasks. We found that the proposed algorithm, when the number of tasks increase, has the smallest make span. And also when become large tasks, our algorithm still provide better results than other algorithms. This is for the second real data set. I think the same behavior of our algorithm. The next application for our meta-heuristic techniques is called parameter estimation of PV or photovoltaic cells. This one can be used for solar energy, or in general, the using of solar energy has been increased since it has a clean source of energy. In this way, the design of photovoltaic cells has attracted the attention of research over the world. Considering the design problem involves the solution of complex nonlinear and multimodal objective function, different algorithms have been proposed to identify the parameter of PV cells and balance. Most of them commonly fail in finding the optimal solution. So we propose in this one a modification algorithm for whale algorithm that called the chaotic whale optimization algorithm that depend on using the chaotic maps and apply them to find the optimal parameter. Actually, in general, there are two model. The first one is called single diet model, and second one is called double diet model. This is the most popular models in PV. However, there is another one that called triple diet model. The most difference between all of them is that single diet model has only 5 parameters needed to be determined during the optimization process. However, double diet model consists of 7 parameters that needed to be determined during the searching process or the design process of PV. This is the algorithm that called the chaotic whale optimization algorithm. And here is this one is the represent the objective functions that needed to be determined, and this is called root mean square error. The results for these techniques for single diet model or double diet model can be seen from this table, and we can see that our algorithm provide nearly the better results than other algorithms. However, most of these results can be we can see that most of them is similar, or most of this algorithms is similar to each other. However, the performance of our algorithm according to the statistical analysis is better than these algorithms. We now going to see how we can using the meta-heuristic techniques in economic applications. This economic application, we start by determine the price or forecasting the price of copper. An accurate forecasting model for the price of minerals plays a vital role in future investments and the decision of mining project and the related companies. We proposed a hybrid model to provide an accurate model for forecasting the copper price. The proposed model combine of using adaptive neurofuzzy inference system and the genetic algorithm. The main aim of using the genetic algorithm are used for estimating the ANFIS model parameters. In general, the ANFIS model can be considered as an extension of a traditional neural network, but combined with a neuro-fuzzy system. In this system, we found that there is 5 layers, and each of them has its own task. The final here of ANFIS, we needed to determine the optimal parameter to obtain the best performance or the best prediction. To find this parameter, we combined the ANFIS with genetic algorithm to determine the parameter of ANFIS. After we combined this ANFIS and the genetic algorithm, we applied for the historical data from copper price from September 1987 to August 27. We divided the dataset here into training and validation. After that, we using some measures such as root mean square error, MSA, and MAE to evaluate the behavior or the performance of our algorithm. We found that the GA with ANFIS still provide better results than other techniques, especially the ANFIS or traditional ANFIS. This is the historical data and the predicted data by using different techniques. And this one also the actually forecasting one. The second application for economic is called oil consumption forecasting. The oil consumption is one of the main factors that affect industry and the economy. Therefore, it is very important to estimate and forecast the consumption of oil. This helps the government to take the right decision and avoid the wrong decision that lead to negative outcomes. For that reason, there are several methods that have been applied to forecast the oil consumption, such as adaptive neural-fuzzy model. It is one of the most popular data mining methods used to perform this forecast. However, the traditional one, as we see before, uh, can be give not good results, and this may be uh, result from the stuck in local optimal or the parameter of the ANFIS is not good. So we needed another technique that can be provide or determine the optimal parameter for ANFIS. We're using here a simple technique that called sine cosine, and we illustrated in the first of our presentation. Here we're using sine cosine only to determine the parameter of ANFIS and using the root mean square error as the objective function. And we apply the proposed model for 3 different countries. The first one is Canada and Germany, and third one is called Japan. And we also divided our dataset into train and testing dataset, and we validated the proposed algorithm by using different measures such as root mean square error, MAE, MABE, and from these results we found that the combination between ANFIS and SCA can provide better results than other techniques that can be combined with ANFIS, especially the genetic algorithms that we used before for other applications. And this is the real data when we compared it for the part of forecasting for each country. Finally, the conclusion and the future work. In general here, there are 3 main major points of this review. The first measure is to illustrate how can we using the meta-heuristic for image segmentation. Second one, how can using the meta-heuristic for global optimization, and how we can improve the behavior of meta-heuristic. The third point or the third measure is to improve the behavior of other algorithms and apply for task scheduling, and also how we can using the meta-heuristic for economic applications. In future work, we can work together if anyone wanted to join to me or my group to work with color image segmentation. Also, maybe we can say our group is the first group to using fractional calculus in improving the meta-heuristic techniques and apply to different application. Also, there are many different works we can work together if anyone prefers to join to me. Thanks to you.